We're going to take a look at 2.3b. It's a lot like 2.3a in the sense that we're going to be going through and we're going to be solving these equations for y. However, we're going to add one extra part to it. We're going to start talking about a y equals mx plus b equation, or what we call in slope-intercept form. In the slope-intercept form, we're looking at y equals mx plus b. And in that form, there's a few things that are given to us. There's an xy point with the y and the x. There's a slope. The slope is the m value, so it's the number that's in front of the x. It's always the number in front of the x. And right now we're just going to be naming the slope. I'll tell you a little bit about the slope as we continue in these sections. But if you remember from this section one thing, I want you to remember that the slope goes with the x. Okay, and so remember that. So we're just going to work on the vocabulary part of that right now. We'll look at the concept part of that being a rate of change, a number that causes a line to be steeper or less steep in some later sections. But right now, know that the slope is the number that goes in front of the x, whether it's a fraction or a decimal or a whole number or in positive or negative. Any of those things doesn't really matter. It's the number that goes with the x. The b portion of y equals mx plus b is the y-intercept. That's the starting point. Okay, so if we think of this in like a story problem type thing, and we'll do more problems with these later, but as a story problem, the y-intercept would be where we're starting. Okay, so if we start at the top of a cliff, if we start at time 0 on the ground, if wherever that starting point is. And we'll do a lot of graphing things with that too, and kind of develop that concept as well. Right now we're looking at the vocabulary part of this. That slope is the m, the number in front of the x, and y-intercept is the number at the end. That's called the constant. So when we go back to this form, we're looking to try to solve this for y. So the goal here would be that you would kind of try to start looking for a pattern in these problems. So I've got x plus 2y. I want to move the x, so I'm going to subtract x from both sides, and I get 2y equals, we want this to be negative x, so we want the x portion to be first, y equals mx plus b, and then we've got plus 6 at the end here. I need to divide the y by 2, but when I divide things by numbers, I want to divide the whole thing, so I get y equals, there's a lazy 1 in front of the x, so I get negative 1/2 x, and then plus 6 divided by 2 is 3. So here's my slope-intercept equation. Okay, so that's the first portion of this, right? Each of the following in slope-intercept form. Be sure to leave the slope as a fraction. We want it to be a fraction. Slope is that constant rate of change, but it also is there's a way for us to remember it that's rise over run. And so if I leave it as a fraction, it's going to be better for me. Don't turn these into decimals. So I get negative 1/2 x plus 3. And then I want to name what my slope is. So the slope is the number that's in front of the x. So that's negative 1/2. It is not negative 1/2 x. Okay, it's the number in front of the x. The x is part of our point, part of the numbers that we're plugging in as independent variables here. Then the b part of this is a positive 3. Okay, so the y-intercept is 3. Slope is negative 1/2, and the y-intercept is 3. That's the process for all of these problems. Okay, and that's the whole thing. So we'll go through and do a couple other ones here, but that really covers the whole gist of everything that we're doing here. Let's jump down to let's say number 5. So I've got 4x minus y, so I need to get rid of the 4x. So I'm going to subtract 4x from both sides. So I get minus y, or negative y, equals negative 4x and then plus 3. I want that x to be first. That's a lazy 1 in front of that y, so I want to divide by negative 1. And I get y equals negative divided by negative is positive. I want to leave this as 4 over 1. You could put it as 4, and that's fine. There's nothing wrong with doing that. But again, we want to kind of think of this slope as a fraction, a rise over run type situation. So 3 divided by negative 1 is negative 3. So there's my slope-intercept equation. I want to name the slope. The slope is the number in front of the x. Either 4 or 4 over 1 is fine. And then I want to name the y-intercept. The y-intercept is a negative 3. The 3 has a negative in front of it, and so the y-intercept is a negative 3. So we're naming that. Now, well, when I go to 8 here, 8 looks like it doesn't have any type of other information in it that is going to help us to write the slope or the y-intercept, but it actually has a lot of information. This is a y equals equation, and so if I were to graph that equation, a y equals is a horizontal equation which goes straight left to right. Now, if I write that with x's in it, I've got y is equal to 0 x's plus 1. Okay, and there weren't any x's in there, so I get y equals 0x plus 1. So now that is my slope-intercept equation. Okay, and so y equals 0x plus 1 is my slope-intercept equation. Y equals 1, sure, that could be your slope-intercept equation too. But since we're looking at trying to learn about the slope here, we want to actually write the x's in there. So I get a slope that's the number in front of the x is a 0. And I get a y-intercept that's the constant at the end, which is a positive 1. Okay, so I get a slope and a y-intercept in that problem as well. When we go to the back here, really all these problems look exactly the same. They have an x in front and a y. That form is called a standard form. So we've got this standard form equation, and then all of a sudden we come to this one in number 17. It's no longer in standard form. It's got no y's in it. So this would be 0 y's plus 1x is equal to 5. Okay, so now look at this as a slope-intercept equation. I want to get the y by itself, so I'm going to subtract 1x. So I get 0y equals negative 1x plus 5. I'm going to divide by 0. And I get y equals, and hopefully you're plugging this into a calculator if you don't understand what's happening here, because when I plug negative 1 divided by 0 into a calculator, it gives me no solution. There's no answer there. Okay, so we end up with not being able to write a slope-intercept equation, which means that my slope, the slope in this problem is undefined. Well, I knew that because the number in front of the x is negative 1 divided by 0. And the y-intercept is a positive 5 divided by 0. Again, I'm dividing by 0. That can't happen. So then the y-intercept, there is no y-intercept in this problem. This is a graph that goes straight up and down. It's an x equals equation. It goes straight up and down at x equals 5. Okay, when it goes straight up and down, that means that the slope is undefined. And unless it actually is the y-axis, it's never going to touch the y-axis. It goes straight up and down, and so it's parallel to that y-axis. And so there's going to be no y-intercept when I look at that as well. I'm going to throw this in here because I want us to start looking at ways to try to remember those two special equations that we looked at. So we've got, this is just an acronym, VUXOI. So VUX is vertical, undefined, x equals. So anytime that I have x equals, I have a vertical line. So that's going to help me graph it when we get to graphing. But it has an undefined slope. Okay, so that's an undefined slope. It's a vertical line, undefined slope, x equals equation. Those are all the three parts that we're going to be looking at of these graphs or these linear equations. Then we've got this HOI part. HOI, the H stands for horizontal. It's a horizontal line if I were to graph it. The O it is actually a 0, so it's a 0 slope, and it's a y equals equation. Okay, and so horizontal line, 0 slope, y equals equation. Just something to keep in mind. The part that we're looking at today is this and this. We're giving an equation, and you needed to define the slope, either an undefined slope or a 0 slope, depending on which equation we had. Okay, so you want to go through, solve the rest of these problems. There aren't any more of these special ones on this worksheet, but when you go through, I want you to name the slope, name the y-intercept, and hopefully you'll have a better understanding as we continue through the rest of these sections, using this Vuxhoy idea, using more of the slope and y-intercept in a visual way as we graph these. But right now I just want you to name them, be able to pull them out of an equation.